Hello students, so welcome back to the channel. So in this video we're going to be introducing and handling trigonometry as applied to pure mathematics. So this video is presented to you by Olgambe Yusuf. You advise subscribe to the channel and then share the video to your colleagues and like the video so that you can all benefit as a team. Now make sure that you address your concerns in the comment section. So let's start. Now when you're looking at trigonometry, we are basically looking at the three trigonometric functions, and that's going to be sine together with tan and cos. So you're going to be looking at how these three trig identities are going to be related in preference to right-angled triangles. So before we start, or before we introduce sine, tan and cos, now we are going to first take a review about our right-angle triangle as we looked at ordinary level. So here we are going to select, consider right-angle triangle with an angle theta, which is going to be acute. And when we say acute, we mean that theta is going to be not exceeding 90 degrees and having an hypotenuse of 1 unit together with x being our opposite and y being our adjacent. So if you look here, the side that has an angle together with the right angled symbol is going to be called the adjacent, and then the side which has the right angle only is what we call the opposite, and then the side which is wrong is what we call the hypotenuse. And these ones can be related using Pythagoras theorem. But now we are going to see how we can express each of the symbols indicated in this right-angle triangle in terms of sine, cos together with tan. So by definition, sine of an angle theta is going to be the same as opposite divided by hypotenuse. So according to our triangle, our opposite is x and then our hypotenuse is 1. So that's why we said sine theta is going to be the same as x over 1, because sine is the same as opposite divided by hypotenuse. So it's going to be x over 1, which is the same as x. And you're going to make a conclusion that implying that x is going to be the same as sine theta. Then you also make a deduction for cos. Now cos can be the same as cosine. So cosine of an angle theta, which is denoted as cos theta, is the same as adjacent divided by hypotenuse. I hope you are told a unique which can help you identify that, which is SOHCAHTOA. So according to SOHCAHTOA, sine is going to be the same as opposite divided by hypotenuse. Then cos is going to be the same as adjacent divided by hypotenuse. And then tan is going to be the same as opposite divided by adjacent. And that's what we call SOHCAHTOA. So you can easily remember these expressions using this short format, that sine is going to be opposite divided by hypotenuse, and then you have to get the symbol on the opposite side and then you divide it by the figure or symbol on the hypotenuse side. You do the same for cos, adjacent divided by hypotenuse, and then you do the same for tan, which is opposite divided by adjacent. So cos is going to be the same as adjacent divided by hypotenuse, and according to this right angle triangle, our adjacent is y and then our hypotenuse is 1. So we make a conclusion that implying that y is going to be the same as cos theta. So from that, we also make the interpretation of tan, which is the same as tangent. So tangent of any angle theta of a right angle triangle, we have said that according to SOHCAHTOA, it's going to be the same as opposite divided by adjacent. So for our opposite, it was x, and then for adjacent, it was y. So we make a conclusion that implying that tan theta is the same as x over y. But remember, our x, from the calculations we have made above, x is the same as sine theta, and then y is the same as cos theta. So we can make a conclusion that tan theta is going to be the same as sine of angle theta divided cos theta. So basically that was the introduction to trig identities of sine, tan, and cos, and I hope you know how to use them appropriately in case you are given a right angled triangle. Now, so let's go to the main or backbone of this video, which is going to be involving special angles together with trigonometric ratios. Now, when we're having special angles in trigonometry and there are only three, that's going to be 30 degrees, 45 degrees, and then 60 degrees. And for each of these angles, you must be clearly in position of stating their fractions according to a right-angled triangle. And you're going to look at that in this video. So you're going to say that for ratios of 30 degrees together with 60 degrees, we are going to get them using an equilateral triangle. When we say an equilateral triangle, we mean a triangle which has equal sides. So for this case, we're going to use a triangle. Each side is going to be of 2 units. And since all sides are equal, that means that each angle is 60 degrees. So if you divide this triangle into two, the angle up here, this side, we are going to have 30 degrees, and then the other side, we are going to have 30 degrees. So let's look at an illustration of that. And then we see how we can express 30 degrees and 60 degrees in terms of ratios. So if you look at this equilateral triangle, we have said that all sides are equal. That means that if this is 2 units, this is also going to be 2 units. Now, because we divided this base, we divided it by 2, it's symmetrical. So when we divide it by this line, when you divide our equilateral triangle by that line, that means that from B to M, distance from B to M is going to be 1 unit. And also the distance from M to C is also going to be 1 unit. So with that, we label each and every, now we have got two right angle triangles. We have right angle triangle A, and we also have right angle triangle B. So for right angle triangle A, base is BM and it's 1 unit. And for right angle triangle B, base is MC and it's also 1 unit. So we want to express our angles, which is 30 degrees together with 60 degrees, in terms of ratios according to this equilateral triangle. Now you should note that we have said that we are going to be using a short form which we have named as SOHCAHTOA. So for this SOHCAHTOA, is going to help us in determining the cosine, the sine, and the tangent of a right angle triangle. So I've said that for sine, when you're dealing with sine, it's going to be the same as opposite divided by hypotenuse. Now remember that you're dealing with two angles. So first, if at all we have to start from sine angle of 60, that means that we need to ignore the 30 degrees angle, and then we take a right angled triangle which has only 60 degrees. So if I'm to take right angled triangle A, then my sketch is going to be of this format. So down here I'm going to have 60 degrees according to that right angled triangle, and then here I'm going to have my angle 90, and then I'm going to ignore the 30 degrees since I'm dealing with sine angle 60. So that means that this is going to be my opposite, and my opposite, according to the sketch, is 1 unit. My hypotenuse is 2 units. And then we have to get our opposite. How can we do that? So from ordinary level, we said that we get the opposite using the Pythagoras theorem. So according to Pythagoras theorem, to get length of AM, length from A to M, we are going to use Pythagoras theorem, and that means that we have to get 2 squared minus 1 squared or under square root, and that's going to give us 4 minus 1 to end up with root of 3. So it means that our opposite side is going to be root of 3. So from here we can get sine 60 tan 60 together with cos 60. So with this, let's start from our SOHCAHTOA. So sine of angle 60 is going to be the same as opposite, and our opposite for this case is root of 3. So it's going to be opposite divided by our hypotenuse, which is 2. So it's going to be root 3 divided by 2. And this is what we call expressing special angles of sine 60 into ratios. You remove it into an angle and then you take it into a ratio. So you also get that of cos. So for cos 60, it's going to be the same as adjacent out of hypotenuse. So our adjacent for this case is 1. We say that adjacent is going to be that side which contains this angle together with this right angled symbol. So adjacent is 1, and then our hypotenuse is 2. So it's going to be sin cos 60 is going to be the same as 1 divided by 2, or it's going to be the same as a half. Then you also get tan 60. So tan 60 according to our sketch, according to this sketch, tan according to SOHCAHTOA is the same as opposite divided by adjacent. And our opposite for this case is the same as root 3. So we're going to say that tan 60 is going to be equal to root 3 divided by our adjacent, which is 1. So it means that tan 60 is the same as root 3. So that's how we are going to be getting special angles of an angle of 60 degrees. Now let's also look at the other side, which is going to be constituting special angles of an angle of 30 degrees. So we say that there's 3 special angles, 30 degrees, 60 degrees together with 45 degrees. And we have looked at so far how we are going to get those of 60 degrees. So let's also look at how we are going to get those of 30 degrees. So in addition with 30 degrees, we are going to ignore the angle 60. And then we take the other sketch. So if you look at the other sketch, if I extract out that triangle, so I'm extracting out this triangle, and my base for this case is going to be MA. So if I'm to label it, this is going to be MA, and then this is going to be B. So remember that angle 60 is at B, so I ignore it since I've already looked at it. And then angle 30 is at A, so we are going to come here and then we indicate 30 degrees here. So for this case, we remember that we got the distance of MA to be root of 3 from this elaboration. And then BM, which was the base initially, is 1 unit. And then our hypotenuse is going to remain 2, which is the same as distance from B to A. So from here, we also use SOHCAHTOA, which is the same as sine being opposite divided by hypotenuse, and then cos being the same as adjacent divided by hypotenuse, and then tan being the same as opposite divided by adjacent. So you're going to use this abbreviation to get all angles, all trig identities of sine, cos, and tan at the angle of 30 degrees. So according to our sketch, let's start with sine. So we say that sine angle 30 is going to be the same as opposite, and the opposite for this case, opposite is the side which has no angle. So our opposite for this case is 1. So it's going to be 1 divided by our hypotenuse, which is 2. So it means that sine 30 degrees is the same as a half. And then cos is the same as adjacent, and our adjacent here is root of 3 divided by our hypotenuse, which is the same as 2. We also get tan of 60 to be equal to opposite, and our opposite here is 1 divided by our adjacent, which for this case is root of 3. So that's how we express trig identities into ratios. So let's make a summary for our angles which we have looked at. So now we are going to come and say that therefore sine of 30, like I've explained, is going to be a half, and then cos of 30 is going to be root of 3 divided by 2. I hope you can see, you can determine and see how we have got this according to the explanation I've just given. This is just a summary of what you have been talking about. So tan of 30 degrees is going to be the same as root 3 divided by 3. Sin 30 is going to be the same as root 3 divided by 2. Cos 60 is going to be the same as a half. And then tan 30 is going to be the same as this. I hope you have understood that. So now let's look at the other special angle, which is going to be a special angle of 45 degrees. So for this special angle, we are saying that we are going to be using a right angle triangle. And for this right angle triangle, we are going to consider that if at all it's right angled, then the angles which are present at these sides, they must be equal. So if at all this is 90 degrees, then we expect this one to be 45 degrees, and also the other angle to be 45 degrees. And the reason why we are doing that is because angles in a triangle sum up to 180 degrees. And since they are equal, so we expect everything to be equal. Now let's look at the sketch and we see how we can get all trig identities under the angle 45 also into trigonometrical ratios. So for that case, this is going to be our sketch. Both of these angles are equal, so it's going to be 45 degrees and 45 degrees. And since it's an isosceles, part of an isosceles triangle, this side is going to be 1 unit together with this side to be 1 unit. So we have to get this side using Pythagoras theorem. And that's going to be, to get hypotenuse using Pythagoras theorem, is going to be the square root of squares of this side, sum of this side together with the sum of this side, which is going to be 1 squared plus 1 squared to be the same as root of 2. So it means that distance P2 is going to be the same as root of 2 units. So from here, we are going to use this triangle to determine, now since angles are equal, we can use any angle. So if I tell you, this is going to be your opposite, which is 1, and then adjacent is also going to be 1, and then hypotenuse is going to be root of 2. So it means that to get sine, remember that from SOHCAHTOA, sine is the same as opposite divided by hypotenuse, and our opposite here is 1 divided by our hypotenuse, which is root of 2. So that's why we are saying that sine of 45 is going to be the same as 1 divided by root of 2. Similarly, cos is the same as adjacent divided by hypotenuse. So cos of 45 is going to be the same as your adjacent is 1, and then your hypotenuse is root of 2. So that's why we express it that way. Then we do also for tan, which is the same as opposite divided by, so tan 45 is going to be opposite, which is 1, divided by adjacent, which is also 1. So tan 45, you should know it in your head that is always going to be 1 unit. So now we have looked at how we can get all those expressions. Now let's look at how we can put them into calculations. So we're going to say that for ratios of 0 or for ratios of other angles that are common, they are going to be go directly using a scientific calculator, as shown in the table below. Now for the angles that we didn't discuss about, which we have said that there are 3 special angles, and we have looked at 30 degrees, and I hope by now you know how to express them into their corresponding ratios. And then you have also looked at 60 degrees, and I hope by now you've also noticed or learned how to convert them into their respective ratios. And you have also looked at 45 degrees, and now you can convert them into the respective ratios of sine, tan together with cos. And for that, if you're having any issue, you try to address it in the comment section. And if you have understood, you like the video so that it gets forwarded to your colleagues who are seeking for the same knowledge. So for the other angles that are going to be common in our assessments and in our items, we are going to be using calculators to attain those angles. So here, the most common angles, most common and obvious, is going to be 90 degrees, 180 degrees, 270 degrees, together with 360 degrees. If you look at all these intervals, you're seeing that we are adding 90 degrees on each and every angle to get the other angle. So with that, if you set sine 0 degrees in your calculator, make sure that your calculator is in degrees or deg. So sine 0 is going to be the same as 0. Also, sine 180 is going to be the same as 0. And also, sine 360 is going to be the same as 0. So that's why we get these answers that are similar, that which angles are going to give us an answer of 0 with a trig identity of sine. So we have seen that when you're having sine of 0, we are always going to have angles of 180 degrees, angles of 0 degrees, together with angles of 360 degrees. That's when you get an answer of 0. That's why here we say that, according to the above table, if at all sine theta is the same as 0, then that means that theta, or the angle that gave us that answer, is most likely to be 0 degrees, 180 degrees, together with 360 degrees. And you should remember that at the back of your mind. Now, if you also look at cos, the angles that give us 0 is going to be 90, is also going to be 270, and it's also going to be nothing else. So you're going to say that if at all you're having cos of angle theta to be equal to 0, then that means that we assume your answer to be given into options. And that's going to be 90 degrees together with 270 degrees. After some time, you're going to be looking at a specific method to derive those formulas other than cramming. But for this case, you just need to understand them. so that when you reach the other side, it's a matter of proving already what you know. So if you go to tan theta, we look at the angles that are going to give us 0 with tan theta, and that's going to be 0 degrees together with 180 plus 360 degrees. And that was the purpose of this table. So when you're looking at this table, you are only spotting which angles are giving you an answer of 0, because it's a summary that you need to keep by your side. So you're going to say that, therefore, according to the above table, for us to have tan of any angle to give us an answer of 0, then that means that we expect our theta to be 0 degrees, 180 degrees, together with 360 degrees. So that was a summary, or that was an introduction to angles, or to obvious angles that are going to be present in this topic. Now let's look at how we are going to be measuring both positive and negative angles. So for this, we have said that angles are going to be measured from the positive x-axis, either going clockwise or going anti-clockwise. So we have two angles. We have angles that are going to be in the positive range. And when it's a positive range, that means that you'll be starting from 0 to any range that has been specified in the question or in the item. And then for negative angles, you're going to be starting from negative 180 to any range that has been specified in the question, but mainly it's going to be 180 degrees Celsius. But for both of them, we are going to be measuring angles starting from the positive x-axis, which is on your right hand side. So we start from here to measure angles. If you're measuring positive angles, you move going anti-clockwise. And then if you're measuring negative angles, you're going to be moving going clockwise. So always remember that for positive angles, we move from the positive x-axis going anti-clockwise. And then for negative angles, which are going to be starting from the range of negative 180, we are going to be moving anti-clockwise. So let's look at the specific elaboration to bring out what you have just talked about. So this is going to be a sketch to know that whenever I'm measuring a positive angle, I'm starting from the positive x-axis for any angle whatsoever. Remember that we are going to look at a quadrant, and we are going to be looking at this abbreviation, implying that for the first quadrant, all trig identities are going to be positive, and then for this one, only sine is positive, for this one, tan is positive, and for this one, cos is positive. But if you are measuring positive angles, you'll be measuring from here to that. If you are getting that of sine, you stop there. If you are getting an angle of tan, you will stop in this quadrant. And if you get an angle of cos, you start from here, stopping here. So this elaboration is just to show you that whenever you are measuring an angle, you should start from the positive x-axis. So this anti-clockwise movement is going to be for positive angles according to the sketch. And then this anti-clockwise movement, or the clockwise movement, is going to be representing a student who is attaining negative angles, or angles that start from negative 180 degrees of range. So with that, let's look at the specific areas of concern. So let's look at trigonometric correlations of any angle. So from here, we are saying that the x and y axis are going to be divided into 4 quadrants. And each quadrant is going to be either measured in terms of anti-clockwise, and this anti-clockwise direction starting from the x-axis, we have said that it's going to be for positive angles. And then for negative angles, we are going to be measuring clockwise. Now let's look at a summary elaborating this. So if you look at this summary, this quadrant is going to be guiding you on whether your answers are supposed to be negative or they are supposed to be positive. So if at all you are given an angle and it lies in the first quadrant, the first quadrant is what we call acute. That means that whichever you are measuring does not exceed 90 degrees. So we call that acute. So in the acute quadrant, we expect all trig identities, which is sine, tan, and cos, to be positive. So if at all your angle is lying here, whichever variable trig function you are dealing with, either sine, tan, or cos, the answers must be positive. And you're going to be looking at how you're going to be doing that in the worked out examples. So if at all your angle lies in the second quadrant, that means that it's only angles of sine that are going to be positive, and then the other angles of other trig identities like tan and cos must be negative. Like I said, we are going to look at worked examples to look at that. But all you should remember is that we measure angles starting from the positive x-axis, going either anti-clockwise for positive angles or going clockwise for negative angles. So this is just a summary of what he's talking about, and you have told you that in the first quadrant all of them are going to be positive. In the second quadrant, only ratios of sine are going to be positive and others are going to be negative. In this third quadrant, it's only tan which is positive and others are going to be negative. And then in the fourth quadrant, it's only cos that is going to be positive and others are going to be negative. So now that being said, let's look at how we can express ratios according to what you have just explained. So if you look at this, this is an acute triangle or an angle which is acute less than 90 degrees. So if at all an angle is acute, we put it in the first quadrant. And remember that we have said that in the first quadrant, all ratios are going to be positive. So we are going to get sine of angle theta 1, and we also get theta 1 is our angle which is here. So we also get cos of theta 1, and we also get tan of theta 1. So sine of theta 1, remember that from SOHCAHTOA, sine is going to be the same as opposite divided by hypotenuse. So our opposite in this case is x. Remember that opposite is that side without an angle. And our adjacent is the side which has an angle together with this symbol of right angled. So for this acute triangle, it's going to be sine to be opposite divided by hypotenuse. And our opposite for this case is x and our hypotenuse is h. So the ratio is going to be positive because in this quadrant, in the first quadrant, all the trig functions are positive. So to get cos is going to be adjacent divided by hypotenuse, and our adjacent is y divided by our hypotenuse, which is the same as h. We also get tan. Tan is the same as opposite divided by adjacent. So our opposite is x divided by our adjacent, which is y. So it's going to be the same as x divided by y. Now let's go to the second quadrant. So in this second quadrant, we call this one obtuse. Obtuse, we mean that angles that do not exceed 180. But remember that you're going to be measuring angles starting from the positive x-axis. But when you're drawing these sketches, you make sure that the angle that you're going to be dealing with must be in a specific triangle, which is horizontal or which is vertical to the x-axis. But we shall look at that later. Let's first look at how we can express this into their respective ratios. So now let's go to the second quadrant. So like we said, in the second quadrant, it's only sine which is positive. That means that other ratios must carry a negative sign. So this is the angle we are measuring. Angles we measure, they start from the positive x-axis. So you see that this side. Now when you're drawing a triangle, when you're drawing this sketch, your angle will be greater than 100, will be greater than 90. So it will be lying in this region. So you have to draw a sketch, but when you're drawing a triangle, you simply draw a vertical line which goes to the x-axis. That's how you obtain this triangle. So for this case, remember that this side is one which has an angle. So y is going to be the adjacent, x is going to be the opposite because we don't have an angle at this corner, and then h is going to be our hypotenuse. So sine theta according to SOHCAHTOA is the same as opposite divided by hypotenuse. So opposite for this case is x, and our hypotenuse is h. And then cos theta is the same as adjacent, which is the same as y, divided by our hypotenuse, which is the same as h. But remember that we are putting a negative sign simply because in the quadrant we are in the second quadrant, it's only sign which is positive. Only sign give us an answer or a ratio which is positive, and other trig identities of tan and cos must carry a negative sign. That's what the other symbol we drew means. Here, the first quadrant, all of them are positive. Here, it's only sign which is positive, and others are going to be negative. And then in the third quadrant, it's only tan which is positive, and others are going to be negative. And then in the fourth quadrant, it's only going to be cos which is positive, and others are going to be negative. So for cos, it's going to be y divided by h, y being your adjacent, h being your hypotenuse. I've said it. You must always remember SOHCAHTOA, showing you that cos is going to be the same as adjacent divided by hypotenuse, and then tan is going to be the same as opposite divided by adjacent, and then sine is going to be the same as opposite divided by hypotenuse. As we proceed, so tan theta is going to be the same as opposite divided by adjacent, and our opposite is x divided by y, but you place the negative on it simply because in the second quadrant, tan together with cos, both of them are negative. That's why after writing the ratios, we give them a negative sign, indicating that these two trig identities or trig functions are negative in the region of angle theta 2. Now let's look at how we can get the angles or the ratios in the third quadrant. Now looking at the third quadrant, remember that you have already handled all, so this is going to be here, all of them are positive, and here only sign is positive. So theta 3, remember that I told you we measure angle starting from the positive x-axis. So from here to here, we also have to measure an angle for that. So when you're sketching that thing, when you're doing your work, you draw a line which goes like this, and you'll say that to draw this triangle, we do not draw it going to the y-axis. We don't do that. We only draw a vertical line going to the x-axis. That's how we end up with this kind of sketch. I hope you understand that. Do not draw a line going to the y-axis, only draw it going to the x-axis. That's how you attain your triangles. So here our adjacent is going to be y, simply because it's near the angle. And then the other side, which is away from the angle, is going to be what we call our opposite. And then the longer side is what we call the hypotenuse. So according to SOHCAHTOA, we are going to find angle theta 3 of cos together with sine together with tan. So sine of angle 3 of theta 3 is going to be the same as x, which is the same as opposite, divided by hypotenuse, which is the same as h. But we attach negative sign on it simply because in the third quadrant, it's only tan which is positive, and other ratios are going to be negative. So it's only the ratio of tan which must be positive, and other ratios must be negative. So that's why sine and cos, they carry the negative sign on their answers other than tan, simply because for tan in that region is only trigonometrical function which is positive. So tan theta 3 is going to be the same as x divided by y, but cos of theta 3 is the same as negative y divided by h, and that simply applies to sine of theta 3. And we get these ratios using SOHCAHTOA, opposite divided by hypotenuse, adjacent divided by hypotenuse together with opposite divided by adjacent. And then we proceed like that. So these two, sine together with cos, are negative simply because in this region it's only tan which is positive, and then others must be attached to a negative sign on their ratios. Now we are going to start to go to the last quadrant, and in this last quadrant it's only cos which is positive, so we only expect cos to have a positive answer, and then we expect other trig identities such as sine and tan to give us negative ratios, simply because in this quadrant, it's only cos which is positive, and other trigonometrical functions give us ratios that must be negative. So adjacent for this case, adjacent is the side near the angle, is going to be y. And then the side which is away from the angle is going to be our opposite. And then the longest side of the triangle is going to be our hypotenuse. So from SOHCAHTOA, sine is going to be the same as opposite divided by hypotenuse. And our opposite for this case is x, and our hypotenuse is h. But remember that for this case, it's only cos which is positive, so we have to put a negative onto our ratio. So it's going to be negative x over h, x being our opposite and h being our hypotenuse. Cos is the same as adjacent divided by hypotenuse, and our adjacent is y divided by our hypotenuse, which is h. But for this case, we didn't put a negative sign simply because in the fourth quadrant, it's only cos which is positive. So if you get tan, it's going to be negative simply because in that quadrant, all functions of tan must be negative. So negative x, which is our opposite, divided by y, which is our adjacent. And this is the idea that you're going to be using to look at the worked examples. So before we start handling the given examples, we are going to note that, so in the first quadrant, when you get an angle theta, it's going to be the same as that very angle, which is the same as alpha. But in the third quadrant, this is simply a summary telling you that if at all you're having your sketch like this, if you get an angle here, it's going to be the same as alpha. But if at all you locate your angle to be this side, for example, if you're dealing with sine, if you're getting an angle of sine, that means that you must be measuring from the positive x-axis to this place. And to measure an angle from here to here, we get the total angle. This is all level work. To measure an angle from here to here, we get the total angle, which is 180, and then we subtract the angle here, which is going to be alpha. So this is simply somebody telling you that if at all you are getting an angle in the second quadrant of sine, it's going to be 180 minus alpha, or minus the angle that you got at first. And then if at all you are getting an angle of tan, because it's tan which is present in this third quadrant, and your sketch is expected to be of the following format. You are going to be getting an angle. We told you that you measure an angle starting from the positive x-axis. So from here to here is already 180. So to get an angle which sums up to this side, that means that you are going to get the angle that you got, because it's the one which is going to be called alpha. So you get the angle which you got initially, and then you add on 180 degrees of an angle. So to get the angle in the third quadrant, it's always going to be 180 then plus this angle, which is alpha. Then for us to get angles in the fourth quadrant, which is the quadrant of cos, for you to get an angle in the fourth quadrant, which is the quadrant of cos, we have to measure from here to here. And to do that, for us to get this angle, we simply get 360, and then we subtract this space, which is going to be 360 minus alpha, or minus the angle that you got initially. So that this is the first triangle. If at all you make notes, make sure that you denote that the first triangle is going to be for positive angles. So the first quadrant, or this first interpretation is going to be for, this is for positive angles when you are dealing with positive ranges, where the given range in the item does not consist of any negative value, meaning that all angles that have been included in the range are all positive. But if at all you're dealing with a negative range, which is going to be ranging from 180 degrees, which is going to be ranging from 180 degrees to 180 degrees, you need to use this interpretation. So for this interpretation, the first part is going to be the same. What this interpretation means is that this one, things above are going to be a mirror of things which are down. So if at all you're having here alpha, when you go down or when you're measuring an angle in the fourth quadrant, you simply get a negative of what is up. So here is going to be, if at all this is alpha, this is going to be negative alpha. If at all this is 180 minus alpha, then we expect the angle down here to be a mirror of this one which is above. So it's going to be negative 180 minus alpha. And you're going to be looking at this in details when you're doing the calculations in the second video. So for now, let's look at the worked examples to see how we can use special angles and different trigonometrical functional ratios. Now this is going to be quite disturbing, but you need to pay close attention. So here you're seeing that the angle that you're dealing with is going to be 135 degrees. So if we make our sketch, 135 degrees is going to be coming from here to around that place. So it means that our sketch is going to be of this format. So we are applying the knowledge that we have got to solve these examples or these tasks. So if you are to do a horizontal line going to the x-axis, our sketch is going to be of this format. So the angle we are dealing with is 135 degrees. So we need to get the angle which is left in this right angle triangle. And that's going to be 180 minus 140 minus 45. Or it's going to be 180 minus 135 to get 45 degrees. So currently we are going to ignore this interpretation. We shall look at it as we progress. So for this, we are going to consider this triangle that to get the angle which is remaining here is going to be 180 minus this angle, which is going to give us 45 degrees. So here, to get sine of angle 45, remember that 45 degrees is a special angle. And we saw that that special angle is coming from this triangle, whereby we say that this is going to be 1, this is also going to be 1, and then this is going to be root of 2. So these are special angles. There are 3 special angles, 45 degrees, 60 degrees, together with 30 degrees. Whenever you get those specific angles, you make sure that you convert them into their respective ratios. So sine of 45 is going to be the same as, according to SOHCAHTOA, is the same as opposite divided by hypotenuse. And our opposite here is 1. Our hypotenuse is root of 2. That's why you're seeing that sine of 45 is going to be the same as 1 divided by root of 2. But remember, we are in the second quadrant. So in this second quadrant, we say that it's only sine which is going to be positive, and other trig identities or trig functions of cos together with tan are going to be negative. So with that, when you're getting other ratios, we make sure that we attach a negative sign on them, simply because our sketch ends in the second quadrant, whereby only sine is positive. So when you're getting cos of angle 45, or cos of 45 of this right angle triangle, is going to be the same as 1 divided by root of 2, but for it is going to be negative. And the reason why it's negative is simply because in this second quadrant, it's only sine which is positive and others are going to be negative. So tan is going to be the same as opposite, which is 1 divided by adjacent, which is also 1. But you put a negative sign on it simply because tan is lying in a quadrant whereby it's negative. It's only sine which is positive in the second quadrant. So I hope you have understood example 1. Now let's go to example 2. So for example 2, we are given an angle of 240 degrees. Now if you look at 240 degrees, if you look at 240 degrees, 240 degrees is exceeding 180. So that means that 240 is going to be lying in this region or in the third quadrant. So for this case, we draw our horizontal line from the x-axis. We say that we don't do it on the y-axis. We draw it always from the x-axis, touching your sketch. So this is going to be our right angle triangle. So for us to get this angle here, we have to get the angle given in the question, and then we subtract 180. So once we do that, you are going to remain with 60 degrees. So if we are to extrapolate out our right angle triangle, which you have drawn on that table, you see that here we are having an angle of 60 degrees, and this is going to be 90. So this side, now remember that 60 degrees, that's a special angle which is coming from an equilateral triangle. And when you're drawing that equilateral triangle, we told you that hypotenuse is going to be 2, then this side, the base is going to be 1, and then this side, which is hypotenuse, is going to be root of 3, using Pythagoras theorem, because it's going to be 2 squared minus 1 squared, which is the same as root of 3. So you're going to come and indicate those specific values up here. So this is going to be, our opposite is going to be root of 3, and then our base is going to be 1, and then our hypotenuse is going to be 2. So we are going to use SOHCAHTOA to determine each and every trig identity of cos, sine together with tan. So from SOHCAHTOA, we say that sine is the same as opposite divided by hypotenuse. And for this case, our opposite is root of 3. Our hypotenuse is 2. That's why you're seeing here is going to be root of 3 divided by 2. But remember that in this quadrant, our sketch is ending in the third quadrant. And in this third quadrant, we say that it's only going to be tan, which is positive. That's why I made a note in this bracket that only tan is positive in this region. So it means that for this answer, for it to be valid, we had to put here a negative on it, simply because other ratios within the third quadrant must be negative. It's only tan which must give us a positive answer. So according to this sketch, we also find cos, and cos is the same as adjacent divided by hypotenuse. So adjacent for this case is 1, and our hypotenuse for this case is 2. That's why we put here cos 60 to be equal to a half. And the answer must be negative, though I forgot it to apply it. Negative simply because it's only tan which is positive in this quadrant. And then we proceed to tan. So tan is going to be opposite, which is same as root of 3 divided by our adjacent, which is same as 1, and you're going to end up with root of 3. So it's only this answer which was supposed to be positive, simply because in the third quadrant, it's only tan which is positive. So you're going to apply the same knowledge, and then we get angles or ratios in the fourth quadrant. So going to the fourth quadrant, now remember that in the fourth quadrant, it's only cos which is going to be positive. That means that other answers must all be negative. So when you come to the fourth quadrant, they give us an angle of 330 degrees. We measure angle starting from the positive x-axis. So it means that that angle is going to be coming up to here. So for me to get a right angle triangle, I draw a vertical line from the x-axis touching my sketch. And then I get an angle here. For me to get an angle here, I'm going to get 360 minus this angle, minus all this angle. So I'll end up with 30 degrees. So this is going to be 90. And then I start attaining what I need. Now since I'm having an angle of 30 degrees, I'm going to go back to my equilateral triangle, and then I see how a triangle of 30 degrees can be attained. So according to my equilateral triangle of special angles, 30 degrees was up here, and then our hypotenuse was 2, our base was 1, and then our height was root of 3 from Pythagoras theorem. So you're going to sketch out this, and if you put that triangle upright, you end up here having 30 degrees. This is going to be 90. So your base, we have said that it's going to be the same as root of 3. And this is going to be adjacent, simply because the side is an angle with an angle. Is a side with an angle. The side without the angle is going to be 1, and then our hypotenuse is going to be 2. But remember that our sketch is lying in the third quadrant. In the third quadrant, it's only cos which is positive. That means that other answers must be negative. So if you come to getting other trig identities using this angle, according to this sketch that you have made, we are going to start with sine. So according to SOHCAHTOA, sine is going to be the same as opposite, and for this case, opposite is 1, divided by our hypotenuse, which is 2. That means that sine of 30 degrees is going to be the same as a half, but you put here negative simply because our sketch was lying in the fourth quadrant where both sine and tan are negative. Going to cos is only positive component in the fourth quadrant. So cos is the same as adjacent, which is the same as root of 3, divided by hypotenuse, which is the same as 2. That's why we ended up with this answer, which must be positive simply because our sketch was lying in the fourth quadrant. And then we go to tan. So tan is the same as opposite divided by adjacent. Our opposite was 1 and adjacent is root of 3. But you put a negative before it simply because in the fourth quadrant, tan is negative. So I hope you have understood that. And if you're understanding, make sure that you like the video. If you're having issues, address them in the comment section. So having looked at that, let's look at the appropriate examples one by one. So for this example, you're given that sine of angle A is the same as 12 divided by 13. Remember that you should always remember SOHCAHTOA. This means that opposite is 12 and then hypotenuse is 13. Now they have told you that angle A is an acute angle. That means that when you're making your sketch, it should be lying in the first quadrant. That's where acute angles lie at. So we are supposed to find the value of cos of A together with tan of A. So we come and then we sketch our sketch. So sine means opposite, which is that, divided by hypotenuse, which is this. So we don't have our adjacent. So we are going to use Pythagoras theorem to determine our adjacent. And with that, it's going to be 13 squared minus 12 squared and the square root to give us 5 units. So for us to get cos A, now remember that in the first quadrant, all ratios are positive. So cos A, remember that from SOHCAHTOA, cos is the same as adjacent, and our adjacent is 5 divided by hypotenuse, which is 13. And then tan is the same as opposite, which is 12, divided by our adjacent, which is 5. All ratios are positive simply because in this first quadrant, all trig functions must be positive. So we don't expect you to write any negative answer. So if you also look at this task, you are being given cos A. Remember that cos is the same as adjacent, which is 24, divided by hypotenuse. And for this case, hypotenuse is 25. So when you're making your sketch, you need to identify whether the angle is acute or obtuse. So for this case, the angle was acute. So being acute, that means that our sketch is going to lie in the first quadrant. That's why when you draw our compass, we put our sketch in the first quadrant. So since they gave us cos is the same as adjacent, which was given as 24, divided by hypotenuse, which was given as 25. So we have to find the opposite side, and we are going to do that by Pythagoras theorem. So according to Pythagoras theorem, 25 squared is the same as x squared plus 24 squared. So if you make x the subject, we have to get 25 squared minus 24 squared, and then we are going to remain with root of 49. And square root of 49 is going to be the same as 7. So we have to get the other values, or we have to find the other tasks that we are being allocated. We have to find the sine, and tan. So none of our answers is going to be negative simply because in the acute area or in the first quadrant, all trig functions must be giving answers that are positive. So sine, according to SOHCAHTOA, is the same as opposite divided by hypotenuse, and our hypotenuse is 25. Our opposite is 7. Tan is the same as opposite, which is 7, divided by adjacent, which is 24. So that was it for that task. So according to the explanations given, this is going to be quite skipped for you to analyze what was taking place. So here the angle is also acute. So that's why the sketch was in that format. So you analyze how we got these respective answers and why each of them is positive. Now let's go to item 4, which is the main point of interest. So if you look at this question, item 4, we are being given that tan theta is same as negative 8 divided by 15. So they gave us an answer which is negative, and they told us it's obtuse. Remember that obtuse? That means that an angle which does not exceed 180. So that means that our sketch is going to be lying in this region. And the reason why they made it negative is because in the second quadrant, which is where our sketch is going to be lying, it's only sign which must be negative, which must be positive. So it means that all answers of tan and cos must be negative. It's only sign which must be positive. So according to tan, 8 is going to be our opposite, and then 15 is going to be adjacent. So you're going to use Pythagoras to find the hypotenuse side. But for this case, the task is to find the value of cosec theta. Now you should have been told that cosec theta is the same as the reciprocal of sine. So cosec theta is the same as 1 out of sine theta. Let's look at the solution for that. So when you're making this sketch, note that we are not going to include this negative simply because the negative is indicating that in this second quadrant, tan is negative. So that's the only meaning of it. So that negative is neither carried by 8 or is neither carried by 15. So in the second quadrant, we simply carry the digits. That this is going to be 8 and then this is going to be 15. The angle is obtuse, that's why we placed it into the second quadrant. So you have to find the value of h, and we shall do that using Pythagoras theorem. So h is going to be the same as 15 squared plus 8 squared, or under square root, and you shall end up with 17. So when you're getting sine, if you're getting other identities, remember that they wanted that to find cosec theta, but cosec theta is a reciprocal of sine, or is the same as 1 out of sine. So to do that, remember that it's only sine which is positive in this region. So sine theta, to get sine theta in this region, is going to be, according to Katoa, is going to be the same as opposite, which is 8, divided by hypotenuse, which is h, and we have got it as 17. So sine theta is the same as 8 divided by 17. And it's positive simply because in this second quadrant, it's only sine which is positive. So we come and say that cosec theta is the same as 1 divided by sine theta. And that means that we have to get the reciprocal of sine. And the reciprocal of sine, which is the same as 8 divided by 17, is going to be the same as 17 divided by 8. And that was the requirements for that item. Now if you look at question 5, we are being told that cos theta is the same as 8 over 17. Given the range of theta, 180 to 360. Now this means the given range is reflex. If we're told something is not acute and is not obtuse, that means that all things that are going to be lying this side are going to be reflex. Now how are you going to know which side you are going to make your sketch at? You look at the given identity, whether it's positive or negative. So according to this identity, they gave us cos and they made it positive. That means that we are going to make our sketch in a quadrant where cos is positive, and that is going to be the fourth quadrant. I hope you have understood that. So since they gave us cos theta and the answer for it is positive, that means that your sketch is going to be in a region where cos is positive, and that is going to be the fourth quadrant. So let's look at how we can find the value of 16 tan theta minus 51 sin theta. Remember, to do this, we have to first find tan theta in terms of ratios and also sin theta in terms of ratios. So let's make a sketch according to this range given. I've said this range is the same as reflex. So I hope everyone knows why we made the sketch in the fourth quadrant. It's because the answer which was given was positive, and cos is only positive in this fourth quadrant. That's why we place our sketch right here. So the side which is close to the angle is our adjacent, and cos is the same as adjacent divided by hypotenuse. and which was given as 8, and the hypotenuse was given as 18. So we have to use Pythagoras theorem to find our opposite. So according to Pythagoras theorem, our opposite is going to be the same as 15. So now we have to get tan theta first, and we also get sin theta, and then we substitute it into our task. So tan theta, according to SOHCAHTOA, is the same as opposite divided by adjacent. But you have made each of them negative simply because in this fourth quadrant, it's only cos which is going to be positive. That means other identities of tan and sine, they must all contain negative ratios. I hope that is clear. So tan is the same as opposite divided by adjacent, and the opposite is 15 divided by 8, but the answer must be negative simply because in the fourth quadrant, only cos is positive. That means that tan and sine, they must be negative. And also sine is the same as negative 15 divided by 17. Similar explanation. So we come to our task, and then we substitute for tan theta, and then we also substitute for sin theta. And if you do that, and you substitute everything in the calculator, you're going to end up with negative 30 plus 45, which is going to give you 15 as the final answer. So looking at item 6, you're being given tan theta, and you're also being told it's reflex. So reflex means that angles that are lying below our obtuse range. So tan theta has been given, in the ratio that has been given is positive. That means that your sketch must be in a region where tan is positive, and that is the third quadrant. So the third quadrant, according to SOHCAHTOA, tan is the same as opposite, which is 7, divided by adjacent, which is 24. So we have to get our hypotenuse using Pythagoras theorem. And if you do that, you end up with 25 being our hypotenuse. So looking at the items given or the tasks, we have to find sec theta. Now sec theta is a reciprocal of cos. Sec theta is the same as 1 divided by cos theta. So before we find sec theta, we have to first find cos. But remember that in this third quadrant, it's only tan which is positive. That means that other ratios that you're trying to get must all be negative. So when you're getting cos, which is the same as adjacent divided by hypotenuse, is going to be the same as negative 24, which is your adjacent, divided by 25, which is your hypotenuse. And you place here this negative simply because in the third quadrant, cos and sine must be negative. So task A, to get sec theta, is going to be the reciprocal of cos theta. We simply get the reciprocal of cos theta, and it's going to be negative 25 divided by 24. So we also get sin theta. So sin theta is also going to be negative simply because in the third quadrant it's only tan which is positive. So it's going to be negative 7 divided by 25. 7 being your opposite and 25 being your hypotenuse. So proceeding, we also look at item 7. So item 7, sin theta is the same as 3 over 5. So you're supposed to carry out a task for finding cos theta and then tan theta. But remember that for this we are given an angle which is unspecified. So if at all it's unspecified, we place it in an angle or we draw a sketch in an area where all angles are positive. If at all they don't tell us whether it's acute, obtuse or reflex, we put it in the first quadrant where all angles are categorized for. So we shall draw sin theta, and sin is the same as opposite, which is the same as 3 divided by hypotenuse, which is 5. So our angle is going to be here. So we have to get x using Pythagoras theorem. So we have to get cos theta, and all our answers are going to be positive simply because in this region all angles are positive simply because we are not given the range. So this was not supposed to be positive or negative, so you simply ignore the signs. It's supposed to be 4 over 5 and also 3 over 4. Now lastly, we are going to look at an item which is going to involve us to use special angles in solving to get a specific answer. So we say that there are 3 special angles. We say that we're having 30 degrees, we're having 60 degrees, and you're also having 45 degrees. Whenever you see these angles, always endeavor to convert those trig functions with those angles into their respective fractions. So according to our fractions, or according to our right angle triangle of angle 45, sine of 45 is going to be the same as 0.5 root of 2, and this is after rationalizing. Let's try to do it quickly. So according to that, sine 45 is going to be the same as 1, which is your opposite, divided by root of 2. But when you're dealing with sides, we say that we don't leave sides in the denominator. So we rationalize this. So it means that 1 out of root 2 is going to be the same as root 2. When you multiply two roots of the same kind, is the same as 2. So this is the same as a half multiplying root of 2. And a half is the same as 0.5 root of 2. So that's why you're seeing that this one is the same as 1 plus 0.5 root of 2, and then the denominator is the same as 1 minus 0.5 root of 2. But here, also here, we don't leave sides in the denominator, so we have to rationalize our denominator by getting the conjugate, or by multiplying both the denominator and the numerator by the conjugate. And the conjugate will simply change the sign. So it's going to be times 1 plus 0.5 root of 2, then times 1 plus 0.5 root of 2. So if you rationalize completely and you open up brackets, we are going to end up with 1 plus root of 2, then plus 0.5, divided by 1 minus 0.5. And if you simplify everything, 1.5 divided by 0.5, we get 3. And also when divide 1 by 0.5, we are going to get 2. So that's why we end up with the final answer of 3 plus 2 root of 2. And that's the end of ratios in trigonometry. So that was it for this video. We are going to meet in the next session where we are going to be talking about trigonometric graphs together with how we can use trigonometric identities in eliminating given parameters. So make sure that you like the video, subscribe to the channel, and share the video to your colleagues. We meet in the next session.